Hi, here's a model of a garbage disposal with an avocado pit. So the blade is in gray. Oops. I yanked part of the basin thing. The blade of the garbage disposal is in gray. More about that in a minute. The circular part of the drain that keeps your avocado pit confined so it can dent the blade is these black circles. The avocado pit, of course, is in a nice tan color. The blade is only set up for impacts with the avocado on one side. So this side of the blade is kind of lifted up out of the way of the detritus. I will hit simulate. Here goes. It says 23 seconds. They run a little slower with my screen capture program on. So you see the blade bops this avocado pit around and around. If you've done this, it's pretty recognizable. We stick with a mathematical model and yet get a kind of behavior that looks a little bit like a video game. We'll slow the animation speed down by a factor of 10. Alright, here's the low speed version. You can see more of what's going on. But it's pretty clear what's going on. One thing you can see better now is that the blade is actually recoiling very slightly when the avocado pit strikes it. And that depends on how strong we make the joint that attaches the blade to this immovable anchor underneath it. So you can see how the blade actually does get thrown around, which is just a fact of life. You can make that joint stronger, but you're always going to have to survive these kind of collisions. Alright, so that goes around and around. Let's do some plots. Probably one of the first things you look at if you're designing these things and curious is how much motor current do we need to make this happen. This is an example where the simulation is going to give us probably more insight than precise numbers. People who have ever read Hamming's book on numerical methods, which is just a classic, almost the classic, he says that the purpose of simulation is insight, not numbers. And here's an example. This is the versus time, 0 seconds, half a second, 1 second on the x-axis. Vertical is the motor current in amperes. So we might have to have the motor, we've seen already in just a couple of seconds of an avocado exposure to an avocado pit, brief currents that are higher than 2.5 amps. We have 48 volts going to the motor, so those are high instantaneous powers. Most of the time, the motor isn't drawing a whole lot of current at all. So this is a very peaky environment for the motor drive circuit and everything behind it. The breadth of these peaks may not be right. For example, if I've put in the wrong elasticity for the surface of an avocado, the peaks might be shorter and broader, although the area might be similar. But it certainly gives you an idea. You're working with this kind of thing, where the motor drive has got to cope with collisions. You're not working with driving a hair dryer or something here. Okay, it's a very tough environment. Another plot we can make is we could plot this on the screen as well, but let's look in the plot window at where the avocado goes. Let's plot the x and y coordinates of this mass that's bouncing around in there. Alright, here's the path that the avocado pit follows, which just looks cool. It bounces off the axis, the outside, and of course the blade, and goes around and around. If we plotted one of these versus time, let's plot the y coordinate versus time. Although the avocado pit goes around and around, we're not going to really see sine or cosine. But it's not entirely different, right? Anything that went around in a circle would look like sine or cosine. This looks like this. So it's not entirely alien to a sinusoid, but it certainly isn't a sinusoid either. You can see when it gets whacked. Alright, let me just try briefly a very slow simulation, slow it down another 10 times, kind of just to show that we can. Aha, here we're running short on frames. So we're showing it so slow that we're getting down to single frames. We can actually beat that by forcing the engine to go to a higher accuracy, and it will calculate more frames for us. But I'm not sure everybody has the patience and interest